dear students. So, now let us discuss about a new test for convergency, that is Dirichlet's test. So this method is used to test the convergency of a series of the form sigma x and y. Sigma x and y. So the test is known as Dirichlet's test. Dirichlet's test. So, to test the convergency of sigma x and yn, let x equals xn be a sequence of decreasing sequence of real numbers with limit xn equals 0. With a limit xn equals 0. Xn be a decreasing sequence of real numbers with a limit xn equals 0, and the partial sum, let Sn be the partial sum of the series sigma yn which is bounded, then the series sigma xn yn is convergent. The partial sum Sn of sigma yn is bounded. This is a crucial point. So this is Dirichlet's test. When x equals xn be a decreasing sequence of real numbers with limit xn equals 0 and Sn be the partial sum of sigma yn which is bounded, then sigma xn yn is convergent. So how to prove this one? So the proof is depends upon Abel's lemma, that is partial summation formula. What is Abel's lemma? If x equals xn be a x equals xn and y equals yn be the sequence of real numbers, then sigma, if m greater than n, then sigma k ranges from n plus 1 to m. Xk yk is same as xm sm minus xn plus 1 sn plus sigma k ranges from n plus 1 to m minus 1 xk minus xk plus 1 into sk. That is where we already proved in previous class. So here sequence, what is Sn? Sn be the partial sum of sigma y and Sn is bounded. Sn is bounded means there exists some m greater than 0 such that modulus of Sn less than or equals m for all n falling n, for all natural numbers n. Modulus of Sn less than or equals n. And what is xn? Secant xn is a decreasing sequence. X equals secant xn being a decreasing sequence. That means xn greater than or equals xn plus 1 for all n falling n. Okay. So by Abel's lemma or summation partial summation formula, sigma k ranges from n plus 1 to m. Xk yk is same as, come on, it is xm xm sm minus xn plus 1 sn plus sigma k ranges from n plus 1 to m minus 1 of xk minus xk plus 1 into sk. Okay. So taking sigma on both sides, that is sigma, modulus on both sides, that is sigma xk yk, where k ranges from n plus 1 to m by s. After taking this modulus, then sigma modulus of xk yk less than or equals modulus of this one plus modulus of this one, triangle inequality. So less than or equals modulus of xm scm minus xn plus 1 sn plus sigma with respect to k that ranges from n plus 1 to m minus 1 of modulus of xk minus xk plus 1 into modulus of sk. Okay. Yes. So which is less than or equals Sm and Sn. Here m greater than n. So listen, the Abel's formula states, or Abel's partial summation formula, or Abel's theorem states that this happens provided m greater than n. Okay, if m greater than n, then sigma k ranges from n plus 1 to m of x k y k is nothing but this one. So since m greater than n, so you can replace this n by m here. So, or n by m greater than n. So it is less than or equals modulus of xm Sn minus this one also. Agree? So take this Sn outside, but modulus of Sn is less than or equals m. So it is less than or equals m into modulus of xn plus 1 or xn plus 1 minus xn. Okay, x m minus xn plus 1, or it is xn plus 1 minus xm. Okay, by because of the modulus. Plus, again, there is a modulus of sk, but it is less than or equals m. So it is m into sigma k ranges from n plus 1 to m minus 1. Then you can distribute this k. Once remains there, it remains modulus of the first term is xn plus 1 minus xn plus 2. The second term is xn plus, then n is n plus 1. So first term is xn plus 1. Listen, the terms are xn plus 1 minus xn plus 2 plus what remains, or by taking this one, what remains xn plus 1 minus xn plus 2 plus, when it is xn plus 2 minus xn plus 3 minus xn plus 3 minus xn, sorry, plus xn plus 3 minus xn plus 4 plus etc. plus the last term k equals m minus 1. So it is xm minus 1 minus xm. Okay, that is the term inside this summation. So what do you get? Plus xn plus 2 minus xn plus 2 cancelling, minus xn plus 3 plus xn plus 3 cancelling, etc. cancelling. So all of these terms are cancelling each other. What remains? Xn plus 1 minus xm. So it is plus m into xn plus 1 minus xm. Okay, xn plus m minus xm means, so here it is m into modulus of, it is m into modulus of xm minus xn plus 1 plus m into modulus of xn plus 1 minus xm. What do you get? So it is less than or equals, it is m into xm and plus minus m into xm and m into this one. So it is 2m into modulus of xn plus 1. Okay, 2m into modulus of xn plus 1, or 2m into modulus of xn, whatever, 2m into modulus of xn plus 1. But what is limit xn? Limit xn equals 0. Limit xn equals 0 means modulus of xn strictly less than some epsilon by m, or epsilon by 2m, whatever may be. Okay, therefore this strictly less than 2m into epsilon by 2m equals epsilon. That means finally you have sigma modulus of xk yk strictly less than epsilon. So by Cauchy's criterion, sigma xn yn is convergent. Okay, yes. So this is Dirichlet's test. So the test is used to check the convergency of the series of the form sigma xn yn when xn is a decreasing sequence of real numbers with a limit xn equals 0. And if the partial sum Sn of sigma yn is bounded, then sigma xn yn converges. This is immediately followed from, or that is heavily depends upon Abel's lemma. That is, when xn is a decreasing sequence, xn greater than or equals xn plus 1. Moreover, since Sn is bounded, modulus of Sn less than or equals m, and by Abel's lemma, k ranges from, if m greater than n, then sigma k ranges from n plus 1 to m of x k y k equals this one. Taking modulus less than or equals m into this one, and if you expand this term by putting k equals n plus 1, n plus 2, etc. up to m minus 1, distributed this k, then it is less than or equals to m into xn plus 1. But limit xn is 0 means modulus of xn less than epsilon by 2m for all epsilon positive and n falling n whatever may be. Then it is strictly less than 2m into epsilon by 2m, that is epsilon. So finally, sigma mod xk yk is strictly less than epsilon. Then by Cauchy's criterion, sigma xk yk converges, therefore sigma, that implies finally sigma xn yn converges. So this is what the requires here. Okay, right. So this is Dirichlet test. So the test is used to test the method is used to test the convergence of sigma x and y. Okay. Now let us consider another test, that is Abel's test. That's also an important one. What is Abel's test? So the hypothesis is, if x equals xn is a convergent monotone sequence, Abel's test. If x equals xn be a sequence of monotone convergent, the series sigma yn is monotone convergent. The series sigma yn is convergent. Sigma yn is the series sigma yn is convergent. Then the series sigma xn yn is also converges. Xn yn also converges. That is Abel's test. If x equals xn is a convergent sequence, monotonically convergent, and sigma yn is convergent series, then sigma xn yn is also convergent. So listen, how to prove this one? The proof is in this way. Let x equals xn be a sequence of monotonically convergent. So x equals xn is monotonically convergent means let x or limit xn or xn converges to x following r. Xn converges to x following r means modulus of xn minus x less than epsilon for all n greater than or equals a particular stage by the definition of the convergence. Let x equals xn is monotonically convergent. Suppose xn converges to x. Then there are two cases arises. If xn is a case first, if xn is a decreasing sequence or increasing sequence, there are two cases. If xn is a decreasing sequence, sequence xn is decreasing monotonically. Why? Because it is only given x equals xn is a monotonical sequence, monotonically convergent sequence. Either it is monotonically decreasing or it is monotonically increasing. So first we consider the sequence xn is monotonically decreasing. So put a un equals, but xn converges to x. Put a sequence un equals xn minus x. What is x? X be the convergent point of sequence x. Since xn is monotonically decreasing, what is un? Clearly sequence un is monotonically decreasing. Sequence un is also a decreasing sequence. Un is this one. So what about the limit to un? Limit to un equals the limit of xn minus x. Okay? Equals limit xn minus limit x. What is limit xn? X. Limit x is also x. So limit to un equals 0. Un is monotonically decreasing, or un is a decreasing sequence, and we have limit to un equals 0. Consider these two arguments. Un is a decreasing sequence of real numbers with the limit to un equals 0. Then by Dirichlet's test, by the previous argument, by Dirichlet's test, sigma un yn also converges. Why? Sigma un yn converges. Why? Because yes, what is yn? Sigma yn is a convergent series. Convergent means it is bounded. So you can apply Dirichlet's test here, because un is a decreasing sequence, limit to un equals 0, as well as the partial sum. Since sigma yn converges, it is bounded, its partial sum is also bounded, hence by Dirichlet's test, sigma un yn converges. Okay. But what is un? Un equals xn minus x. Un equals xn minus x. That means un yn equals xn yn minus xy. Okay. So from here, what is x and yn? X and yn equals, it is un, as x and yn equals un minus xy. Agree? That means sigma x and yn equals sigma un yn minus sigma xy. What is sigma un yn? By Dirichlet's test, it is converges. Since yn converges, sigma xyn converges, sigma yn converges, sigma xyn also converges. So from here, we know that sigma x and yn converges. So when xn is monotonically decreasing, sigma x and yn also converges. Now, the second case is when sequence xn is monotonically increasing. What is the next stage? xn is monotonically increasing. When xn is monotonically increasing, put a vn. Put vn equals it is xn minus x. Since xn is monotonically increasing, clearly this implies vn, sequence vn is also monotonically increasing. Moreover, what is limit vn? Again, limit vn equals limit xn minus x, that's also 0. So vn is monotonically increasing and limit yn equals 0. Okay, monotonically increasing and limit yn equals 0. Now, put a vn equals xn minus x. So, vn is increasing sequence. If vn equals x minus x, what do you get? Vn equals x minus xn. Since xn is monotonically increasing, therefore sequence vn is monotonically decreasing. Okay, put a vn equals x minus xn. Then since xn is monotonically increasing, then vn is monotonically decreasing. Vn is monotonically decreasing and limit yn equals 0. Then by Dirichlet's test, sigma vn by n is also converges. Okay. Why? Because sigma yn converges, it's bounded, partial sum is also bounded, then you can apply the Dirichlet's test, so sigma vn by n is also converges. But what about vn by n? From here, vn by n equals xyn minus xn. Okay, that means xn by n equals, bring this one, so it is xyn minus vn by n. Agreed? Then that means sigma xn by n equals sigma xyn minus sigma vn by n. What is sigma vn by n? Converges. Sigma yn converges, so sigma xyn also converges. Therefore, this also implies sigma xn by n converges. So this is Abel's test. X is monotonical, that means it is monotonically increasing or monotonically decreasing. When it is monotonically increasing, clearly it is converges. Again, the case first also shows that when it is monotonically decreasing, it also converges. So, the Abel's test that states that when x equals xn be a sequence of monotonically convergent and sigma by n is converging, then sigma xn by n also converges. This is Abel's test. Okay, right.